All right. Hey, welcome here. This is Dr. Jon here with extraktTalks. How are you doing today? Today we're going to be talking about some of the greatest topics in all the world related to extraction, of course, because that's what we do.
Extraction and hash.
And hash. This is going to be, this is a verboten topic among us self-admitted CO2 lovers and connoisseurs, right?
Extractioneers.
Yeah,
I like to throw out there.
Yes. So we're going to be talking a little bit about that today. We're going to be going over a lot of the different topics related to what those extracts are, some of the issues associated with the extracts, what the benefits are of those extracts, and so we're just going to have a good time kind of discussing.
Yep.
So
how can it not be when you're talking about hash
and
that's
extraction?
Right.
That's right. So let's kind of get into this. You know, honestly, I've never run a butane extraction before.
Okay.
I've done every possible type of liquid extraction. I did gas, liquid membrane separations. I've done gas separations with membranes.
Right.
I haven't really used in my repertoire of experience. I really haven't done any butane stuff. So I know you have.
A little bit.
Yeah, a little bit.
Just a little bit.
Why don't you kind of take us through it? We got an expert here.
Well, I'd say, I got started extracting initially with hydrocarbons. Initially, it started with butane, then went into N-butane, and then, tri-blends using butane, propane, and butane combined. About 12 years ago, did the standard open blast, Bob's Backyard Blasters, and tried to figure it out. Don't recommend that.
I do take it back. I did that. I did that with some guys. Yeah. So that's where you take the tube. You're doing the stuff, and you take the tube and you stick it out the window.
Yeah. Make sure the fans are blowing.
Make sure the fans are blowing out, and it shouldn't be a problem. Then you have a little butane can from that you would use for fill your cigarette lighter.
Yeah.
Yeah. You definitely get extract out of that.
Yeah.
So.
And it works. It's easy, right? It's the solubility with hydrocarbon and the cannabinoids it's really good. Mm-hmm. And one of the benefits of using these hydrocarbons is it doesn't pull a lot of fats, waxes, or lipids. The boiling point on these hydrocarbons are extremely low, so you're not gassing off or cooking off any of those good terpenes that we're all after. So there's some really good benefits for the consumer side, right, to using these solvents as an extract. Mm-hmm. It's just once I learned how to use CO2 appropriately, it was why even mess with this, right? Like I was having a conversation earlier. Yes, hydrocarbon extraction it can be safe. It can be done very safely, right? But I'm a firm believer that just because it hasn't happened to you doesn't mean it's not going to. When I'm talking about dangerous operations, it's only a matter of time before that spark happens.
Well,
only a matter of time.
Absolutely. So you hit on a couple different things that I'd like to ask you about. Mm-hmm. First of all, don't you usually purge the extract after it comes out of the butane extractor?
Yeah, otherwise you're smoking sparklers. Absolutely, yeah.
So that means that even though the boiling point is really low, you still have to purge it under vacuum in order to get it out, right?
Absolutely.
So you'd have the hash oil, you put it onto some parchment paper or a stainless steel, whatever, and then you put it into a vacuum oven, right? And you're pulling the vacuum, right?
Correct.
So you're trying to get that
last 3 to 5% of solvent out of
which is
that.
going to stick in there, right?
Yes. Yeah. Gets difficult.
Properly purged, extract. Does it have any of the butane left in it, or is it pretty much done?
It's pretty much done. However, I think the guidelines follow FDA parts per million, right? So I'm now a firm believer that just because they say you can have a certain amount in it doesn't mean that you should. Right. 5,000 parts per million. Like, yes, that's acceptable. However, like, why add more chemical load to your body if you don't need to? Right.
Well, yeah. Okay. So let's kind of talk about that then from a couple different perspectives. The butane that you typically would use, I assume it's a food grade butane,
correct,
right?
Yep.
So, okay. So you're doing that butane. You have it. There's a specification there. Are there impurities in that butane that may not purge out of the extract?
Possible, but depending on how you're operating. Mm-hmm. So if you're using Bob's Backyard Blaster method, you can absolutely have contaminants in that solvent, right? But currently, like traditional closed loop systems have a solvent filter on them essentially, right? So they're passing that solvent through a filtration that's kind of removing any of those inconsistencies or issues within the solvent.
What kind of filtration are you talking about?
So it can be silica is used, bentonite clays are used, things like that.
Mm-hmm.
It's used for solvent recovery and also in line for a filtration method on the back end of the actual extraction process to remove any additional fats or waxes that made its way through.
Okay, I see. So like, for example, if you had like a benzene contaminant in a butane, right, there's always going to be some, different hydrocarbons,
Right.
Whether they're aromatic or not, that could be in there. If you pass that through a silica column or you pass that through bentonite clay, it wouldn't have any selectivity.
No.
It would just go right through.
Correct.
Have you ever seen like a C of A for butane at all? I'm curious.
For a butane, for actual solvent?
Yeah.
No,
Right.
just the standard SMS sheets that come with it.
I have some pretty good, we've seen really good detailed CFAs for like ethanol. So we know what's in the ethanol, the 200 proof ethanol. Very, very, there's always a little tiny bit of methanol in there.
Right.
And there's other small things, maybe acetone or something like that within your ethanol, even if it's food grade, very, very small amount, for the subparts per million.
Right.
But, I guess I don't know what the food grade butane C of A looks like.
Yeah, I've never
Does
seen
it
one.
have-
I
yeah.
typically go off of, it says that it's 99.8% pure or 98% pure,
Right.
and we kind of run with it.
So you purge it then. And so that's the purpose of getting that stuff out. So, okay, so if you do have butane or any of the other components that would go into the butane, certainly if you're using like the little can for the Zippo lighter,
Yeah.
you're definitely not food grade.
No,
with
not
that,
at all.
Right.
Right.
So yeah, I think one of the things that typically with a food grade type of element, also the conditions of use are really important. So, I mean, right, like for example, if you have, it makes a difference if you're combusting the end product or if you're actually consuming it as an ingestible, right? So if you have butane you're consuming as an ingestible, it's not being combusted, right?
Right.
And if they use it as a propellant in other foods and things like that, that should be okay.
Right.
But if you're combusting it, you're now creating other side products that are different.
Exactly.
Unless the FDA looks specifically at that condition of use, so they approve it. Like the FDA approves it for use as a propellant for various things, right?
Non-stick sprays or whatever.
Or whatever it is. But if then if it's combusted, that would be something. I'm thinking like a Cheese Whiz or something like that.
And it changes everything.
It changes everything.
Absolutely.
Right? Yeah. So so that's the whole discussion there about the cleanliness, the input materials. I mean, obviously that's really important.
Always. And gold in, gold out, and that not just for the material that you're using, but the solvents you're using as well.
Right.
You want to make sure everything is clean and non-contaminated.
Right. One of the things about butane is really talking a little bit about the greenness of the solvent. So before we move on into all the extracts and stuff, I kind of want to hit the main point, things that I was thinking about. I don't think butane is a GHG gas, is it?
No.
Okay,
No, sir.
so it's a green thing, right? I suppose if you ran a butane extractor in a GMP environment, you would have to verify that you didn't have contaminants coming through every time, right? And you'd probably have a maximum number of use that you could use for that butane. So then the question is, then what do you do to get rid of that butane after it's done, right?
Sounds like a hazmat disposal.
Hazmat disposal,
right?
yeah, I think so. Or hazmat medical waste disposal.
There you go.
That's probably more likely.
And when you say that, I just hear money being spent.
Ka-ching, ka-ching, So I don't think it necessarily is a green issue. I guess if you brought it to a waste disposal site, they probably would burn it, right? So it would just go up, as CO2. So,
right.
Probably that's not that big of a deal.
No, it just has to make sure it's safe.
Yeah.
It's going to be a big boom if you burn it. That's
if
for
you
sure.
burn it really quickly, all at once. Yeah. So, all right. So, so let's move on then.
Okay. I'd say consumers like butane or even propane extracts because of the versatility.
Yeah.
Right. So when we're looking at a dispensary shelf and we see crumble, we see shatter, we see sugar, we see live resin, we see batter, all of those are traditional hydrocarbon extracts, right? And they're all extracted the same way. It's just how are they post-produced or refined after the initial crude extraction is completed. You might be whipping it heavily adding some oxygen into that product, right? You might just be putting it straight into the vacuum oven to create some shatter. So it's just about the post-production side. But it gives you different SKUs, different products to put on the shelf using the same extraction method,
Right.
to kind of give you different, access to different revenue streams.
Right.
Each consumer prefers their specific type of extract. So being able to make that whole array is ideal because you can target everyone that way, right? But again, I learned that you can do the same thing with CO2 if you know how to use it. So if you're running in the right parameters and using the right systems, why even use hydrocarbons? Why make yourself at risk in any form or fashion? Because it's only a matter of time before something bad happens.
Right.
Only a matter of time. So if you can switch from that and kind of focus more on sustainable and life-saving sustainable operations, then by all means do so.
Right. Okay, so let's kind of get into that. I mean, how would you go about creating a CO2 shatter?
Well, it comes back to extraction parameters, right? So CO2 is known to pull more fats, waxes, and lipids during the extraction. But what we found is that if you reduce that temperature and pressure, mainly that pressure of the CO2, and go super subcritical, we're talking 300 to 500 psi subcritical CO2. We're in liquid phase, so now we're mimicking
cold, I guess.
Very, very cold, right? So roughly -20, -30 C, right? We're mimicking the same solubility band as a hydrocarbon, specifically and butane. So now we can extract the same products, the same target molecules, using CO2 in a much safer fashion, right? And you're running low pressure, so you don't have to worry about the high pressure, super critical pressures that you'd normally be running with CO2 extraction.
Right. And why would you want to do that? I guess because you would want to create the shatters, you would want to create the waxes, you would want to create those products.
And you're preserving that terpene. Those terpene profiles are essential to the concentrate market, right? It's essential to the functionality of the extract as well on the consumer side. So if we can mimic other extraction bands and preserve the terpene profiles in the extract, you're going to come out with a product that's extremely desirable.
Right. Okay. So, all right. So let's kind of go through. So you're saying 300 to 500 psi, right? How cold do you need to have this?
-20, -30 C is normally ideal. If you're familiar with like the winterization process, right? We know that -30 C is typically where you're at for the separation and precipitation of fats, waxes, and lipids.
Right.
So if we can conduct an extract for ethanol, if we can mimic that temperature, then we are mitigating the extraction or removal of those products in the initial crude extraction.
Okay. So let's talk a little bit about decarboxylation in this step. Then, are you talking about a decarboxylated material or just a regular straight up material?
So it depends on the desired output. But if we're looking for shatter, wax, batter, those types of products, we're not decarbing beforehand, right? We want to preserve all of the terpenes because those get cooked off in the decarb process, and we want to ensure that we're extracting the acid form of the molecule.
Right. Okay. So do you get so then all of the terpenes are going into it, so it's kind of like a sauce that you're getting out of it?
Yep. And it comes back to, just like hydrocarbons, the post-processing, the refinement part of the extraction. What we do at the end after we have the crude determines or dictates what the shelf product is going to be, right? So if we're making shatter, we're going to take that crude extract, we're going to throw it straight into a vacuum oven, run as deep vacuum as we can, and start pulling and get that product or extract as stable as possible, right? If we're looking to make a crumble or a batter, we're going to whip it. And we're going to agitate a lot of that extract and keep whipping, and we're going to add oxygen to it, which is going to stabilize it in a different way, and it's going to firm it up and create a crumble or batter product, right?
Okay.
So it's all about the post-processing. It's the same post-processing requirements that you would have for hydrocarbons, right? Just using CO2.
Would you purge in this case?
You don't necessarily need to. Okay. CO2 is not dangerous. At all. It's going to naturally gas off in your processes. And it also comes down to what the final end product desired is. So if we're looking for a super stable, safe to touch, meaning it's not tacky, sticky, crumble type extract, we're not going to purge it all.
Okay.
We're going to let that CO2 sit in there, let that product stabilize as much as possible.
Right.
And then chop it up and put it on the shelf.
One thing that I always wondered about was, okay, if you put a butane extract into a oven,
Mm-hmm.
heat it up under vacuum, how then are you preserving the terpenes? They're coming off.
Low and slow.
Okay.
That's the ticket, right?
So how low a temperature are we talking about?
So usually I in the past haven't gone above 60, 70 C at the most.
So all your monoterpenes are gone.
Yes.
Especially.
Absolutely.
Yeah.
Yep.
And so some of your diterpenes are also volatilizing.
Right.
Depends on your vacuum. Right?
Now, if we are looking to make a live resin, let's say,
Mm-hmm.
then we are putting it in the vacuum oven. We are just pulling vacuum and letting it sit.
Okay.
Right? We're not at all adding additional heat to start cooking that off. However, that takes a lot longer on the post-processing side, right? Because now we're running it a longer time under vacuum.
So still the monos would go off though.
No heat, but you are losing some monos, absolutely.
Because of the vacuum, right? So you're basically lowering the boiling point,
right?
So okay, all right. So I guess, have you ever done that and then check to see how much terpenes you get off?
The terpene loss?
Yeah.
No, I've never actually analyzed that. Okay,
that'd be kind of interesting to see. So, all right. So that's one thing. One thing that I'm always concerned about or listening for is, GMP extracts versus like consumer extracts, right? And there's probably totally different goals.
Very much so.
Probably in the consumer side, you have the goal of taste and flavor, right? So you want to have all the terpenes in there. In the case of a GMP extract, you would want to try to remove those so that they wouldn't be, give you an unstable stability profile, right? So let's talk first about the consumer side. You had mentioned taste and flavor and preserving all those. Do you preserve them by, basically within the CO2 or the butane, you're preserving them, are taking the extracts and then storing them in a tight container, or under what conditions do you typically store something like that?
So normally
for the consumer side,
put it in a cold cooler, right, or a refrigerator is always ideal. Now, keeping in mind, once they're packaged for consumer consumption, they're in jars, right, or they're, depending on where you're at, on parchment paper in a Mylar bag.
Right.
So the moment that comes out of that chilled environment, you're losing, right? Because there's no way to stop that degradation. It's a natural process.
Yeah, right. Yeah, exactly. Okay, and the same thing would go for CO2 then too?
Yeah, absolutely.
Yeah. Okay, so compare and contrast that, say, with a GMP extract.
Right.
You're looking to get something that's stable, that's going to have a good shelf life, that's not going to be changing out over time. So in that case, for a GMP pharmaceutical extract, you might want to actually remove all the terpenes, and that would be your main goal. And then, or maybe remove, preserve, and then add back in, but still in the end product, it would still have that, constant degradation going on.
Right. So it's that creating a standardized extract, as you would say. Right?
Yeah, exactly. Okay, so that's something. One thing that you had mentioned very early on in the conversation was about pulling lipids versus not pulling lipids. Could you kind of go into that? Because I know that a lot of the literature, and I've watched people. Typically you find some lipids in there, or decolorization. Decolorization and lipids. Can we kind of go through some of that related to the butane and how that will affect the quality of the extract?
So you're pulling less when using hydrocarbons, right? It's a solubility, right? So
you're only doing it a small amount.
You're only pulling a small amount of lipids compared to other extraction methods.
Right.
Absolutely. Which then gives you the ability to make those other products.
Right.
But you can mimic that process using low pressure liquid CO2. Right. So, I think that lipids on the consumer side, they add a different flavor, right? A different profile to the extract, which can have like this weird nutty back end flavor on the tongue or in the mouth, which is not always ideal.
Right.
So figuring out a way to remove those from the extract is always ideal.
Right.
So again, low pressure liquid CO2 allows you to mimic that and mitigate all those issues.
Yeah. Okay. So do you typically get any lipids then with a low pressure CO2?
You still will. You absolutely will. And the same thing with hydrocarbon. You're going to pull some. It's going to happen.
But you typically don't deal with them. They just you just use them as they are because they're so small amount.
Right. It's such a
Yeah.
small amount that it's not going to be harmful to
Right.
anyone's using and consuming it. There was, questions of popcorn lung or lipid lung years ago, and it's just not something that we see because it's such a small amount. We're not combusting or vaporizing a gallon of, MCT and taking that into the body. It's not that amount. It's a very, very small amount.
Yeah. Okay. All right. Sounds good. Okay. Well, that's amazing. So can you do a compare and contrast then between these beautiful CO2 extracts that you get out versus the butane? I mean, basically flavor profile,
Mm-hmm.
check.
Yep. Check. Flavors comparable, absolutely comparable. I would say in some aspects, the CO2 does provide a better flavor profile if you run the proper methods.
Okay.
If we're talking about malleability, end product consistency, check. Right, you can make the same product with CO2 as you can with hydrocarbons, and that's saying shatter, wax, even live resin.
Mm-hmm.
Right, we can even manufacture or create THCA diamonds in terp sauce using CO2.
That's
right.
Customers do that.
Absolutely. Yeah. So again, why take the risk?
Yeah.
Why take the risk? It just doesn't make sense to me.
Right. Let's talk about a little bit of operating cost stuff.
Mm-hmm.
So. First of all, we can talk about the consumer and then the GMP. Obviously, we know the GMP is more expensive because you're not going to be able to use the butane more than twice or three times, maybe if you're lucky, due to the entrainment and recycling of the compounds that are in there. So that's probably the most expensive, right? And then you won't be able to scale it up either because you have a maximum amount of butane that you can have in a facility, right?
Unless you get an H-rated facility.
An H-rated facility.
Then you're talking several $1 million in infrastructure. It's just not feasible.
Right. That's called that's classification, right? Building classification. Yep. So you have F1, F2 for those of you who know industrial classifications. That have solvents, and there's maximum amounts. You can look up all the details of that with the International Fire Code.
There you go.
And then there's also H designations, which are for like explosive conditions and things like that. So you can look up, and there's crazy amounts of requirements. You have to.
Yes, it gets expensive very quickly.
Yeah,
very quickly.
Things that you wouldn't really normally think of.
No. Every light switch, every motor for your HVAC's got to be spark proof, fireproof. Right. It gets crazy pretty fast.
Like for example, if a butane explosion does happen, what are we talking about for fire mitigation? I mean, it's probably not water.
No. It's the thing with these hydrocarbons is it's a quick explosion, very quick burn, right? So it looks amazing. It doesn't burn long. But there's a lot of force that gets generated through that quick burn.
It's a blast.
Right? It's a big blast. So you're going to get a lot of damage really fast, and it's going to burn off fairly quickly.
Right.
But it's still going to create a lot of damage. And there's images, there's videos all over the internet showing what the end or the outcome looks like when these things go wrong.
Yeah, we've seen that a lot.
Not with CO2 though. You never see that with CO2. No.
We have seen there are some people who have had issues.
Yes.
And it's where they're using butane, low pressure, unapproved, and it blows up and they're like, oh, the CO2.
Yep.
I heard about a guy who did that.
Yep. So I've heard of doing a co-solvent with butane. And I do know another gentleman that's no longer with us that actually used limonene as a co-solvent. Right. And that created immense pressure. And his equipment wasn't up to snuff, and unfortunately,
Yeah. So if you're doing any kind of pressure with using those low pressure, sanitary spools and things like that, they're not really rated. And a lot of the closures are, have butane screws, or they have brass screws.
Brass screws. Yes.
So if you use them, they come off.
Yeah. They wear very quickly.
Yeah.
Very quickly.
So any kind of pressurized container, it's got to be really essentially open if you're going to use it, which really defeats the purposes of butane in the first place, right? You have to have it closed in order to remain liquid. So, okay. Good deal. Well, that's been very informative. Thanks a lot, man.
Here to help.
If you guys want to learn more about CO2 and you want to learn more about butane and how you might use CO2 in a safer manner to create wonderful tasting extracts for the consumer market, make sure you give us a call. Stefan here is an expert on this, has been doing it for many years, and we can get you the information that you need along with the equipment that you need to really make that happen.
Absolutely. We're here to help wherever we can.
All right. Thanks a lot, guys. Take care.
Care.